This is Lab 2, which is a continuation of Lab 1. Lab 1 and 2 are about error detection and correction. So in Lab 1, we're focusing on finding parities from characters, but in Lab 2, we're focusing on finding parities by looking at binary numbers, which also consists of ones and zeros. But in this lab, we want to calculate the parity on the actual bit itself. So in our parity.c file, we were able to find the parity of characters by essentially creating a loop and counting the number of ones, and then using a modulus to determine whether the parity is odd or even. We know how modulus works, knowing that remainders means that the number is odd, or when there are no remainders, the number is even. We also returned error by checking the buff, which is a string, and checking whether or not the character had any characters that were not ones or zeros. In Lab 1, we compared characters, whether or not the characters were 1 or 0 characters, but in Lab 2, we want to calculate the parity of the binary data. So in Lab 2, in order to check the parity of the binary data, we apply the same logic in Lab 1, which is letting the user know if there's an error in the data so that it stops doing any work. And if there are no issues, then return whether or not the parity is odd or even when given the command arguments. So that logic can be applied to Lab 2 as well. So first, we've declared our variables, but now a new variable is in parity.c, which is the unsigned car iMask that is in the main function, which we have set to 0x80, and that is equivalent to saying that is 10000000, which will be helpful in going through the binary data. So now we have to convert our string into bits and filter that binary data and produce an error message, which is done in the main function. So when the command argument is not a 1 or a 0, we'll send out an error message, which is here. But now that we've converted our strings to bits, we want to create a way to go through each individual bit. In order to do that, we need a loop. We need a loop through the bytes, so we look at each individual byte and then go one at a time through the bits. To do this, we use a for loop, and iBuff length is keeping track of the bytes. We don't need an increment in the for loop because we want to look at each bit inside that byte, so we leave that incrementing for later. To add to the total number of ones, we can use the digital logic AND to help us know when to increment some ones. So we can look at an example. We know what iMask is, which is this, and we can make a value for star buff, which we know star buff is what's stored. So we can say it is this, for example. So in this particular example, because the first bit are both ones, it'll return true. So because it returns true, then we can add to the total number of ones. If not, we don't add to the total. So now we need to take care of how we can move on to the next bit. To do this, we have to add another if statement in our loop so we can move on to the next bit. This happens when iMask reaches 0. So when iMask reaches 0, then we can go to the next bit. It also means we can go to the next bit in buff. So then we can increment both, and when iMask also reaches 0, we also need to reset iMask to repeat the task, which is why we reset iMask back to 0x80. Then this part of the code is just borrowed from Lab 1 because we are, again, wanting to check whether or not the parity is odd or even, which can be done using the same idea in Lab 1 by using the modulus. This is why we can borrow that part of the code, and now that the code is complete, Lab 2 is done and we can run the code. So we can right-click and go to Properties and look at debugging and then our command arguments. So the first command argument is 010. That should give us a odd parity, and then the next one should give us an even parity, and then the next one should output that there's an error. So when we run it, so when we compare Lab 1 and Lab 2 results, in our first command argument, we'll get an odd parity. In our second command argument, we'll get an even parity, and we'll get an error message for the third command argument. But where it differs is what is printed to the user when we get that error message, and that is Lab